Okay, we are looking at our 8-4 notes on horizontal asymptotes. So first, we must look at the largest exponents in the numerator and the denominator. And when we do this, there are 3 possibilities. So we have 3 possibilities, and we're going to have 3 rules. So this is one of those ones where we're going to use it, and you're going to know the rules. First, if the largest exponent is in the numerator, the largest exponent in the numerator is less than the largest exponent in the denominator, then the horizontal asymptote is y equals 0. So there is no mathematical we have to find it. It's just a rule. So if you look at this, the highest degree in the numerator is x squared, and the highest degree in the denominator is x to the 7th. So my numerator exponent is less than my denominator exponent, so I have a horizontal asymptote at y equals 0. That is it. There's no math to do, no solving. That is just it. Okay. So if you look, do you see that this graph is coming down? It looks like it's hitting 0, but it's just going to run along it on both sides. Okay. Now, second, this is the second rule. If the largest exponent in the numerator is equal to the largest exponent in the denominator. So you're going to want these in standard form. We want to look at this before it's factored. And if it's already factored, we need to unfactor it. So do you see that my powers are the same? Do we see that the powers are the same? Okay. So you're going to take the coefficients from each one. So what's the coefficient of the numerator? 3. What's the leading coefficient of the denominator? 6. So you would look at this and say, hey, I have a horizontal asymptote at 3 over 6, but what is 3 over 6? So you always reduce it. So if a fraction, reduce it. Okay, so let's repeat this. If your numerator degree is smaller than your denominator, it's just an automatic y equals 0. It doesn't matter what numbers you have, it's y equals 0. If your powers are the same, your leading coefficients are then pooled to make a fraction. It's like we take from each because they're the same. And then the last one is if the exponent in the numerator is greater than the exponent in the denominator, then there is no horizontal asymptote. So you'd write none or you'd write NA. Now, if you look at this, we can see that there's a vertical asymptote here, and we can see a vertical asymptote here. But there's no horizontal asymptote because this just bounces and it goes back up. Okay, so not every graph has a horizontal asymptote. I'm suggesting a note card, and you sort of write these 3 rules, maybe an example, and that's it. It's either y equals 0, it's the coefficients of the same power, or there is no horizontal asymptote. Like, those are the rules. Okay, so here we go. Now, if I only asked you for the horizontal asymptote, you would look at this and say, hey, the numerator degree is 1, the denominator degree is 2. If my numerator degree is smaller than my denominator, what is my horizontal asymptote? But you wouldn't just write 0. What would you write? Y equals, because it's cutting through the y-axis. Okay, so if all I asked you for was the horizontal asymptote, you're done. Y equals 0. But I am asking you to find the domain, and I'm asking you to find all vertical and all horizontal asymptotes. All right, how do I find the domain and the vertical asymptotes? I'm going to factor it. So the top is just x. How does that bottom factor? X minus 3 and x plus 1. I need you guys double checking your factoring. You need to double check your signs, because if this is off, then all of these answers are wrong. Okay, so my denominator cannot equal 0. That's giving me my domain. So we want x to not be 3, and we want x to not be negative 1. So I'm okay with you giving me the domain restriction for the domain. If you did interval notation, you've got to do a lot of pieces. Okay, what are my vertical asymptotes? Well, did anything cancel? Did anything reduce in this problem? Okay, so everything that's here would create a vertical asymptote. So I'd have one vertical asymptote at x equals 3 and one vertical asymptote at x equals negative 1. So I'll say this again. You are welcome to list your domain restrictions. X cannot equal, but vertical asymptotes have to stand alone with their own x equals because you're defining 2 different vertical lines. Got it? Okay, next one. the numerator power is greater than the denominator power. So what's my horizontal asymptote? With no work, just looking at the powers and the leading terms, there would be none. Okay, to find my domain, we need to factor. So take a quick second, factor the bottom. Again, these right now are a little bit easier factoring because A is 1. What are you doing? What are your numbers? Okay, so whatever order you have it in, I have +5 and -4. We get that +1 in the middle. So my domain restrictions are that x cannot be -5 and +4. Does anything cancel out here? Nothing cancels, agreed? So this didn't reduce anything, so both of my domain restrictions are going to create those vertical asymptotes where the graph is going to approach, but it will not cross over x equals -5, and it will not cross over x equals 4. Okay, look at the next one. So your horizontal asymptote is the quickest thing to do, and it's before you do any work. However, if I pre-factored this, if it was in pieces, you would need to put those pieces together to look at that leading term. You want to write it in standard form. My numerator degree is the same as my denominator degree. So what is my horizontal asymptote? But you're going to write y equals 2/3, right? So if my degrees are the same, I pull those leading coefficients. I take one from each. Okay, now I need a factor. Well, the top factors and it's a difference of squares. And go ahead and factor. I'm going to take the GCF out of the bottom because that's going to make my life easier, and I'd have to do it anyway. And the bottom factors. All right, are we in agreement here with our factoring? Do you see why I always want to take that GCF out? It makes it so much easier because now my factoring with smaller numbers with A is 1. Okay, it says this cleans up. What happens? A 1-to-1 ratio, can't we cancel out one of these x plus 2's? It's a 1-to-1 ratio though, so I'm stuck with that extra one. So the top is 2x minus 2, and what's in the bottom? 3x plus 2. All right, my domain restrictions come from the original denominator, right? Guys, is 3 going to cause any domain restrictions? I had some people telling me that this would be 0. When would I get a domain restriction of 0 is if I have an x, like a 3x, just x by itself. Okay, I'd have a domain restriction of -2. Now, here's the deal. This canceled out, but I still have that down there, right? So I have a domain restriction, x cannot be -2. My vertical asymptote, even though it canceled out, I still had one there, is at x equals -2. So yes, this canceled, but my vertical asymptotes come from the reduced denominator. Got it? All right, I'll give you a second and you try the last one. All right, this numerator factors out a 2, and I'm left with x squared minus 4 and 2x, doesn't it? Okay, so is that better? It's just a 2x out front, and down here is going to be x minus 4, x plus 3. Okay, I think I saved myself there. So I took out a 2x, that should not be there. And then, does anything cancel here? Yeah, the x minus 4's cancel. All right, let me fix this up here, maybe. All right, so we should have that 2x out front, and then the x minus 4 is going to cancel. So the cleaned up is going to be 2x on the top and x plus 3 on the bottom. Okay, my domain restrictions come from before I canceled. So domain restrictions would be that x cannot be 4 or -3. Agreed? Now, domain restriction, x cannot be, make sure you have your x cannot be, or whatever the variable is, cannot be 4 or -3. Vertical asymptote comes from what's left in the denominator, so that's only at x equals -3. And the vertical asymptote, go back to the beginning, my powers were the same, weren't they? So it'd be 2 over 1 or y equals 2. So we're focused on domains, vertical and horizontal asymptotes. What I want to throw out to you is whatever canceled from my denominator, the next lesson we're going to see that's that hole in the graph where it's going to skip over it, but it's not going to completely block it.